Hey everybody, this is going to be a long video, not going to lie. Thank you, Roxanne, for asking me how to do this. This is a three-variable, equation problem. So I'm going to kind of walk you through those three equations. So I have it already written out. I'm just going to go through explaining it. So these were the three equations that we started off with up here, these three. So the first thing I'm going to want to do is I noticed that we have a positive z here and a negative z. So the first thing I'm going to do is I'm just going to eliminate the z by just adding those two together. So there's the first equation and the second equation. So we just add them together like we normally do a system of equations. We add them together, we get 6x. These two add up to be negative 3y. These z's are going to cancel each other out, and then we add negative 6 and a positive 8, and we get 2. So now what we're going to do is we're going to create this using this equation. Now we're going to create a fourth equation. So that would be right over here. So I just wrote it out so you can see it. And then we're going to now go through the whole process of eliminating the z from the first equation and that third equation. So we're going to start off by subtracting the first minus the third. So basically what I have here is I have a subtraction of this entire equation. This is the third equation, and then I rewrote it. So subtracting a negative 2x gives me a positive 2x. Subtracting a positive 5y gives me a negative 5y. And then subtracting a negative z would give me a positive z. And then I do the same thing over here. So subtracting a negative 39 gives me minus 39. So I kind of just put a little light line through that so that you can see that I rewrote it right here. And now I'm going to go ahead and I'm going to combine those. X plus 2x is 3x. Negative y minus 5y is negative 6y. The z plus z is 2z. You know, you're probably thinking, well, why did you do that? Because you didn't eliminate anything. Just relax. Negative 6 minus 39 will give me negative 45. So this is now going to be considered the next equation, what I'm going to do, and I kind of just wrote this down so you can see. Then I'm going to multiply the first equation by 2, which is what's going to get you the elimination. So we had this equation right here. And we're going to multiply the first equation, which is this, x minus y plus z equals negative 6. Multiply the entire thing by 2. And so I circled what the new equation is when you do that. 2 times x is 2x, 2 times negative y is negative 2y, 2 times z is 2z, and then 2 times a negative 6 is not negative 6, sorry. That should be 12, my bad. All right, let's try that again. There, okay. I think I did my stuff right though. Yeah, okay, sorry, I did that, I don't know what I was thinking. All right, so now what I have here is this, and we're gonna take this equation and we're gonna subtract it. So this is gonna be fixable, hold on. So this is gonna be actually negative 12, which ended up being positive 12 here. There, that should fix that. Sorry about that. This is why this is already 3.5 minutes, almost 4 minutes, and it's already taken me this long, and it's already written. So when I multiplied this entire equation right here by 2, this is what I got. This is a negative 12. So now I'm going to take it, I'm going to subtract it, this whole thing, which is right here. So subtracting 2x gives me minus 2x. Subtracting negative 2y is actually plus 2y. Subtracting 2x actually gives me negative 2z. Did I say 2z? And then minus negative 12 gives me a positive 12. Now I'll combine those two together. 3 minus 2 is x. Negative 6y plus 2y is 4y, negative 4y. And then the z's are now going to cancel. And then negative 45 plus 12 gives me negative 33. So that is now going to become my fifth equation. So I just put that over here so you can see. There's your fifth equation right there. And now we're going to use just these two equations and solve them like elimination system of linear equations with just two variables. So what I'm going to do now is I'm going to take this and this. These are the fourth and the fifth equations that I created without z in it. and I multiply the second one, or I should say the fifth one, by -6 so I can cancel the 6 x's out. So I multiply this entire equation, the second equation without z on it, which is number 5's equation, and this times this is -6x, this times this is positive 24y, this times this is a positive 198. Now I canceled that out, just kind of rewrote it. 6 plus -6 gives me nothing. -3y plus 24y gives me 21y. And then 2 plus 198 is 200. Get the 21 out of there by dividing both sides by 21, and you're left with this icky number, which is 200 over 21. So that's your y. Now what I'm going to do is I'm going to go into the second equation without z, which would be your fifth equation. That's this equation right here. And using that y value that we just got, we're going to sub it in right there. So as you can see, there it is right here. So x minus 4 times this now 200 over 21 equals -33. We solve that, we get x equals this times this is -800 over 21. And then I just changed the -33 to 21st. So I multiplied 33 times 21, -33. Then I got -693 over 21. So now I can combine like terms. So I have to add 800 21sts to both sides, and then you end up getting x equaling 107 over 21. So that's 2 of my variables. Now what I'm going to do is I'm going to go back all the way back up here to originally the first equation. Now that I have x, now that I have y, all I got to do is solve for z. So down here, I'm going to solve for z, plugging in my x value here, my y value here, and then we're going to do plus z equals -6. And then I just changed the -6 to a -126 over 21 because we have 21sts, so I want to keep it consistent. I combined 107 minus 200 21sts, and I got -93 21sts plus our z, which is equal to -126 over 21. Add 93 21sts to both sides, and you end up getting z equaling -33 over 21, which then reduces down to -11 sevenths. So our 3 answers for all of these questions would be 107 over 21 for our x, comma 200 over 21 for our y, and then -11 sevenths for our z. Sorry that was a long one, but if you want more questions like this, don't ask me to do them. No, I'm just kidding. These are a little bit tricky and a little hard to do, but I don't do them too often, so hopefully this made sense, and I hope that it helped. If it does, let me know. If it didn't, I'm sorry I butchered it, but this is how you do it by hand. And if you want more questions like this, you can find them on my YouTube, my Instagram, and my TikTok. YouWantAlgebra, and you can find these under the Systems of Equations section.